So it says at the top of the page, consider the trigonometric equation secant of theta equals 2 square root 3 over 3. The plan outlined below is the process that we're going to use to solve the equation of this kind. We're looking for two values of theta that fall between 0 and 360. So right now, we're in degrees, not radians. They told you that when they put that interval up there. I told you the other day, almost always with a trig equation, they're going to give you some sort of interval to narrow it down because trig functions are infinite. They go on forever, so there could be a million answers. So they're going to give you an interval. This time, it's 0 to 360, which means we're going around the unit circle one time. So we've got to look for all the answers that fall in the unit circle that first time, and this time it's in degrees. This is how most of the time they're going to tell you whether you're supposed to be in degrees or radians. If this were a calculator question, which it's not, but if it were, that would tell you what you were supposed to do with the mode on the calculator. So you have to know, you can't, not once you're into trig, I can't tell you what mode to put your calculator in because you're going to go back and forth between degrees and radians. But you have to know they're not going to tell you, switch your calculator to degrees. They're not going to do that. They're just going to tell you an interval and you're going to have to be aware. But this time, no calculator anyway, so it doesn't matter. Okay, so the first step says, if necessary, rewrite the equation in terms of sine, cosine, or tangent. That's because sine, cosine, and tangent are the ones that we can tell most easily from the unit circle, because the ordered pair is cosine, sine. So we prefer for all of our trig ratios to be the original three, sine, cosine, or tangent. So the first thing we're going to do is take secant and fix it so that it is in terms of sine, cosine, or tangent. So which one does secant go with? Okay, so secant goes with cosine, and secant is cosine flipped over. So that's the first thing you're going to do, is take this and make it cosine of theta, which means I have to flip this over. Now, the rational is on bottom. So let's go ahead and rationalize this, because rationalizing it is actually going to simplify this for us. And you'll get good enough that you can probably flip them without having to rationalize them and do it all in your head. So when I do that, I end up with 3 square roots of 3 over 2 times 3, right? Because down here on bottom, where you had square root of 3 times square root of 3, it canceled the radical. Which actually means I can cancel these 3's. Is everybody okay? Does that make sense? So now what we actually have is square root of 3 over 2. Okay, so then it says, make a note of the 2 possible quadrants of determination for theta based on the sine of theta. So this time, my cosine is positive. So cosine of theta is greater than 0 in what 2 quadrants?
2 and 4. 1 and 4. 1 and 4. Yeah.
1 and 4. Alright, so currently I have cosine of theta equals square root of 3 over 2. Now, remember, theta is just a variable, like x. It just happens to be a Greek letter. Instead of using an Arabic letter like x, we're using a Greek letter, theta. But that's what we're looking for. And anytime you're solving something, you need to get that variable by itself. You need to get x alone, isolate x. In this case, we're isolating theta. And right now, theta has the word cosine with it. So I've got to get rid of the word cosine. How do you get rid of it? Arc cosine, or inverse cosine. So if I inverse cosine this side, cosine to the negative 1, I have to inverse cosine this side. Now, the only problem is we can't use our calculator. If they were letting you use your calculator, which, by the way, you'll take your quiz on Friday. On Monday, we'll go over the quiz, anything you missed on the quiz, and talk a little bit about mistakes you might have made. And Tuesday, there will be a test. Tuesday will be the calculator portion of the test. Wednesday, you will take a test the half of the test that is non-calculator. So if you had a question like this on Wednesday where you can't use your calculator, you have to arc cosine without your calculator. But it's easier than you think. All you have to do is think about where are the places on the unit circle where cosine is square root of 3 over 2. So in my mind, I just go left-hand trick. Cosine is x, so I need 3 fingers on top, right? Which means if I fold in this finger, I'm at the place where cosine is square root of 3 over 2. Well, what is that finger?
Pi over 6.
Pi over 6. So at pi over 6, square root of 3 over 2 is cosine. So you just inverse cosine without your calculator. So I now know that theta equals pi over 6. Okay, so then it says, draw the angle that you found in step 3 in standard position. This angle should terminate in one of the 2 quadrants that I mentioned in step 2. Does that angle terminate in a quadrant that I mentioned? It does, because it's pi over 6. So, okay, so pi over 6 is in the correct quadrant. So I need the one in quadrant 4 that also has a 6 on bottom. So it says draw the second angle in standard position. This angle should have the same reference angle as your first and terminate in the other of the 2 quadrants. So down here in quadrant 4, I should have one. I'm going to draw an arrow to say that it went all the way around. And that one would be 11 pi over 6. So you just solved a trigonometric equation. Because now we know that theta equals pi over 6 and 11 pi over 6. Now, it could equal a lot of other things too. Oh, except for they ask us in degrees. So we have to tell it in degrees now.
32.
So what is pi over 6 in degrees? 30. And what would 11 pi over 6 be in degrees? 330. But they limited us to that, but we could go around and around and around again. Because technically, 390 would be an answer. We can go all the way around again, but this time they limited you just to between 0 and 360. Okay, so is everybody kind of sort of okay? Yes, ma'am. Sure, absolutely. Okay, so this is that's the coordinate grid. This is the first side of the unit circle. So 0 is here. The one smack in the middle is 45, or pi over 4. They're the same thing. And then right here is pi over 6, which is also 30. And up here is pi over 3, which is 60. And then, of course, 90 is straight up, which is pi over 2. Okay, so your left hand, if you put your left hand down, back of your hand on the page, your pinky is 0. Your thumb is 90. Your fingers in between represent the other 3 angles. So if you want to know what ordered pair is at a certain place, you fold in that finger. So if they said 30 degrees, that's this finger. So I fold it in. The 3 fingers on top represent the X value, and the finger on bottom represents the Y. So I know I've got this, 3 and 1. But there's always a square root on the top piece, and a 2 on the bottom. The only thing you have to fix is what is the square root of 1? 1. So there really doesn't have to be a square root on there. So it ends up being square root of 3 over 2 and 1/2. So if you fold in this finger, the 2 fingers on top are your X values, that's a 2. The 2 fingers on bottom are your Y value. They have square root signs over them always, and they're always over 2. So you can remember your order pairs. Okay, so let's do the same thing. It says using the same plan described above. They didn't give you little boxes to write in, but you're going to do the same thing. This time you're doing sine of theta at negative square root 3 over 2. So you go step by step, follow the steps above, and see if you can get it, and then we'll go over it.